Is anybody tired? No? Because I see these chairs. You guys are sitting, I'm standing. I don't have a computer in front of me, so I feel pretty naked. Actually, this thing's transparent also. So it's nothing to hide, okay, here. She stumbled on the keyword unleashing. Back in December, I was proposing the abstract, said, you have a great topic, Jose, but just in case, if you get allocated a slot in the last day in the afternoon, you had to have a very intriguing title. And I hope I did to keep you in the room. I hope nobody's being forced to be here, and you want to hear what I'm about to say. And it is very important because we're bringing traffic engineering to the masses. We have the problems that everybody's trying to solve in a simple way. Some of you alluded to simplicity a moment ago. So let's get going. One of the reasons why we're here is trying to answer almost philosophical questions out there. Have you ever tried to tell the IGP what to do? Tell ISIS, tell OSPF what you really wanted and achieve a path that is for you your macro traffic engineer policy or desire. Arrive at a destination minimizing the delay. Arrive at a destination utilizing only encrypted links. Arriving at a destination that only uses the high-speed links and leaves the others behind. Arriving at a destination using only a subset of your topology and not using nodes because for political or regulation reasons, you cannot go. And all of these use cases are available now. This is not your basic segment routing 101 presentation. Just make it clear. What we are here talking about the newest member of the segment routing traffic engineering family. Her name is SR-IGP flexible algorithms. So now you know her. You're going to know her more in the next 25 minutes to understand what can you accomplish with it. So we're going to break it into 3 sections. Overview, get everybody excited, I hope. How it works, boring. Protocol, use cases, good. Okay, those are the 3 sections. Now, what I mentioned earlier is to really look at SR-IGP flexible algorithm as a segment routing traffic engineering toolkit, the newest toolkit. But it's one that must not be thought in isolation. It needs to compenetrate with everything else that you have in your segment routing traffic engineering toolkit, whether it is TI-LFA, on-demand policy creation, or automated steering. These last 2 points are key for the newest, and I'm happy to hear that word because it makes sense, is intent. The ability to have traffic engineer path that put traffic into an object when it's needed and stop when it's not needed. We call them a flex algo. And why flex? Is because you decide what it will do. You could have a flex algo where you will indicate to your IGP that you want to perform path computation to minimize based on a metric, IGP or delay. You will also tell the IGP to exclude resources based on link affinities or SRLGs. So you pack this information, the IGP, you will see what he will do, and then will compute a path to honor your minimization objective and to honor your constraints. What really makes the point is what's on the slide. Imagine you have a topology with 8 routers, as shown on the lower left-hand side, and you decide that you want to have a red shadow area. Everybody calls this now a slice. I have a network slice that only includes 5 out of my 8 routers, and I want my IGP to compute a path to any destination in the slice that minimizes the IGP metric and avoids the brown links. What you see in the blue arrow is a representation of such a path. Who made that call that they wanted to avoid brown and include only these routers? You made that call. The operator did. In the next example, the same operator or another operator, I guess it's the same because it has the same topology, it has the same routers in the so-called slice, but this time he wants to minimize on the delay to reach the destination. Now you see a completely different path to go from node 6 to node 4 in the violet arrow. 2 completely different objectives between 2 destinations. And that is what flexible algorithm is trying to do. But really, the point to bring home is these questions. How many MPLS labels were needed to instantiate the blue or the violet arrow? And the answer is 1 label. So what we're here is to introduce the new Flex Algo seed. It's a customizable prefix seed that you tell the router what it means. It could mean get to the destination minimizing delay, get to the destination minimizing IGP, and avoiding brown. And now with that instruction, which is a single label, you realize your traffic engineer path. If you read a lot into it, and if you read what I wrote, I'm doing a SR traffic engineering policy with a single label, which many people who may see a lot of benefits on doing that, whether it is the imposition at the source, a router that cannot impose 9 or 10 labels. Well, what about if he can impose 3? Can I ask him to impose 1? Sure you can. What about in the middle, back to ECMP? If I need to ECMP and I have MPLS, multiple MPLS next hops, which one do I choose? I want to go down into the packet. Can you ECMP when you get 1 label from the source? Yes, you can. So how it works? We begin from the foundation, and the first foundation concept is membership. A node in your IGP will be declared a member of a Flex Algo. We call them by letters. You will see them in reality, they're really instance numbers, but we call it Flex Algo K. Routers in this picture, you see how many? 10 of them. All the routers are part of the algorithm 0, which includes all 10 routers. 6 of them on the top will be green routers, router 0, router 9, and the green routers are the Flex Algo for Algo 128, and the bottom routers are my red routers, my algorithm 129. Okay. As you can see, a node can belong to 1 or multiple Flex Algos. A Flex Algo can be enabled on all the nodes or a subset of the nodes. The next concept is, what does the router advertise? When a router belongs in a Flex Algo, he will advertise a Flex Algo seed. Otherwise, there's no point for him to be on that Flex Algo. So in this picture, if you look at router number 9, he will advertise a label for all the Flex Algos that he belongs to. And you see the label values on the screen, 16,009 as an example, 16,809, 16,909 for the different Flex Algos. Node number 2, on the other hand, he belongs to only 1 Flex Algo and the Algo 0. So he advertises 2 labels. And when I said labels, I mean labels associated to what? To a single prefix. So if you look, router 9 has 1 loopback, 1.1.1.9, and multiple labels advertised for that loopback. The same label numbers I told you in the previous slide. So you should be able to come in and say, one loopback, multiple labels. Now, each label has a completely different meaning to get to 9. I want to get to 9 considering the entire topology, or get to 9 according to my FlexAlgo 128, or get to 9 according to FlexAlgo 129. So let's summarize the operation. 4 main steps. I mentioned the first one already, membership. I belong. If you look at the upper right-hand side, I borrow the topology from before. I have a node N, and he's exposed to a topology that has FlexAlgos K and P. Well, N is told to be told of FlexAlgo K. Every router in a FlexAlgo needs to know the definition of the FlexAlgo, and that definition has to be consistent. And one of the main things that you will see later in the IETF is to have a very solid mechanism to achieve consistent definition of the FlexAlgos. How do I know the definition? You decide the definition of the FlexAlgo. That's why it's called Flex. Then the definition has to be told to the members of the FlexAlgo. You can include the definition as part of your day 0 automation. When you configure node N, you tell him the definition. Or the definition can also be learned through flooding in the IGP. So I'm a member. I know what is the definition of the FlexAlgo. The next step is I need to compute paths in the FlexAlgo. Now, if you look at the pictures in the upper right-hand side, you see 3 pictures. The picture of the entire graph of nodes in the topology. The next picture only includes the router in the FlexAlgo 128 graph. And the last graph is the FlexAlgo 129, or FlexAlgo P, as I call it. So what N will do is he will run multiple Dijkstra's, one for FlexAlgos, for Algo 0, which includes everybody. And then he says, wait a moment, I'm a member of FlexAlgo K. K happens to be the red topology you see third in the picture. He will remove any node that is not in FlexAlgo K. He will prune any node that is being excluded from FlexAlgo K, and the result is what we call the topology of K. And this is the topology that I use to compute my Dijkstra for any destinations that are in the topology of K, according to the metric of K. And you decide what's going to be the metric of K, IGP, TE, or delay. So now it's time to move from control to data plane. So now I have the different routers who advertise the FlexAlgo prefix seats in K. Now I need to program the reachability. So N will install a label cross-connect in FIB to reach the destinations in topology K. Those destinations will be along the shortest path to them, computed by IGP. At the very beginning, I mentioned that this solution is completely ingrained with the SRT toolkit and the SR architecture. And the most important piece to highlight now is LFA and TI-LFA. The TI-LFA algorithm is executed per FlexAlgo topology. So if I ask for a FlexAlgo to compute a primary path to minimize on delay, the backup path will minimize on delay. Even more, the backup path will stay among the members of the FlexAlgo. I will never leave my topology. FlexAlgo K has a topology K. Out of that topology, I have to come up with primary and backups. And they're both optimized for the objective that you told me to do. So now we arrive at a very important milestone. I'm able to do traffic engineering with one label to achieve the goals that I put into the IGP. My backup path will obey the same rules, and it will stay in the same flex algo topology. Take as an example the case of a random topology like the one showing, where all the routers belong to the algo 0 and the algo 128. The algo 128 has a special clause. I want to avoid the red link. And now what you see in the slide is the primary path to go from 1 to 3 according to algo 0 and algo 128. They are the same. Node 3 has one loopback and two labels, algo 0 label and algo 128 label for his loopback 1.1.3. So far, there is no mystery here. Same path for both flex algo. The backup paths that TI-LFA will compute are going to be different. The backup path that I compute in algo 0, if you follow the gray and then the blue arrow, will go over the red link. So algo 0 is allowed to use the entire topology. And that is what I did with the backup path of algo 0. However, look at the backup path of algo 128, which is gray arrow and then the violet arrow. It avoids the red link. So primary path, backup path follow the same rules as the topology of your flex algo. Okay. It's very important because as we move into some of the use cases, some customers by design, by business, were not allowed to leave the confine of their slice no matter what. Not even for 20, 30, or 40 micros or milliseconds of backup enforcement. Always in the slice. Everything I show until now, and maybe I may have slipped the word ISIS, even though I was trying to be careful and say always IGP, is because this solution is protocol agnostic. It applies to ISIS, it applies to OSPF. This solution is data plane agnostic. It applies to SR-MPLS, it applies to SRv6. This solution is not a Cisco proprietary solution. We already have all the drafts, and you will see them here, on how the flex algo solution was already born 4 years ago. 4 years ago, when you open the architecture draft at the IETF, there is a particular area that most likely got omitted by many people reading, which is the presence of an algorithm number when you signal a prefix SID. The algorithm field was already in the books 4 years ago. So there you can refresh your memory and see the algo concept in the advertising of a prefix SID. The segment routing policy draft includes all the behaviors that I'm going to show you in the use case, like on-demand policy instantiation and automated steering. Because nobody makes money just building an IGP path, which is traffic engineer. I have to put services on those paths. So you need to care what's happening on the head end to put my customer traffic into that path. But the new draft that for sure some of you may have noticed is the third draft on the slide that defines the extensions to ISIS and OSPF to advertise the definition of a flex algo. We called it the FAD, the FAD. There is another draft that also, well, for those of you who want to optimize multi-domain networks and you're using a segment routing PCE, how can the PCE learn these flex algo topologies? So then you have extensions to BGPLS to propagate the flex algo topology definition to the controller. And then the next two are existing drafts that probably leave for your reading. Okay. This is the interesting part in my view, because I told you things, maybe people who already have problems are already realizing how this can be useful to them. I will tell you what is being useful to many of the Cisco customers that we interact. Well, the picture that I was using all throughout this presentation is nothing but the multi-plane design. A multiplane design that is realized so trivially that there is no tomorrow for multiplane now. You can have your green plane, you can have your red plane, you can have nodes like 0 and 9 that belongs to both planes. You can define how you route in the plane because it's your algo, it's flex. I can do IGP minimization in the green plane, I can do delay minimization in the red plane. I can make the planes overlap. I can do whatever I want from that point of view. So what would happen if node number 0 were to send traffic imposing the label that I show with the gray background, which is 16,009. 16,009 is the prefix seed of algo 0 of the loopback of 9. I think by now, many of you may realize what's going to happen to that traffic. I'm going to load balance across both planes, and I'm going to load balance within each plane. So multi-plane ECMP and intra-plane ECMP. This is what happens today. So nothing new. This is my algo 0, everything. Okay? Remember, actually I didn't say this. In all of this until now, there's only one IGP process. There is no multiple IGPs. It's one loopback, one IGP process in this whole discussion here. Back to simplicity, okay? What would happen if node number 0 wanted to send traffic to node 9 and he wants to push the green label, the label 16,809, which is representation of the loopback of 9 in flex algo 128. I no longer will do ECMP onto the planes. I only go to the green plane. And then I do ECMP in the green plane. Again, one label allows my entire network to realize this multiplane behavior. The next one is obvious now. If you were to push the red label of 9, you know what's going to happen. You go down. So multiplane use case is one of the leading use cases of people who are looking to implement flex algo as quickly as they can. The next point is a point of how do we connect flex algo with traffic engineering at the head end, and especially how do I put traffic into the flex algo. For those of you who are familiar with iOS XR, I leave you some iOS XR CLI, but for those of you who prefer to read English, I just want you to read the blue text. What I have done in here is I have told my head ends, watch for routes with color 100. Color 100 is the intent that I put on my network. I now have a service, a BGP service route, an EVPN or an IPVPN route that is coming with a color community. It's a color community with a value of 100. I know that if I receive 100, I want to reach the BGP next hop of that route using the flex algo 128 prefix seed of my BGP next hop. And I'm done. Let's look at an example. The same multiplane topology, the sample configuration I gave you in the previous slide, which is basically intent 100 means flex algo 128. Now, router number 9 is advertising a BPN before prefix, EVPN route. Doesn't matter. I have a color on that route with a color 100. You see that in green. The route is coming with a BGP next hop of 9. With the template I told you in the previous slide, which is configured on node 0, with that template, I'm going to program directly in fib an entry for that prefix where I'm going to push 2 labels. The first label is the BPN label of my prefix or my BRF, which in this case is 80,000. The next label is the prefix seed 128 algo label of my BGP next hop for that prefix, which is 16,809. directly. So fib is directly programmed to put the traffic into the flex algo path. There is no other feature you are doing onto the ingress router. All you did at service provisioning is provision the service with the intent. And the intent was this color 100. Now, when I receive traffic for that destination, the traffic will automatically go only onto the green plane. We call this behavior on the head end automated steering. But what would have happened if the prefix that came from 9 came with no color? It didn't come with the color 100. At least I'm not showing you any color there. So in that case, I will program directly to my algorithm 0 label of my BGP next hop, which is 16,009, followed by the BPN label 70,000 in this case. So now my traffic will go across any plane. All of this intent and this coloring, we're showing it to you here at a per prefix level. So you could have all the prefixes in a service have the same intent, or you can change the color per intent. Something we're not showing you, we don't have time for that. You can also place intent per flow as well. It's a very powerful concept. The second use case has to do with delay optimized routing. I have a topology I show you in the upper right-hand side. In that topology, there are some green numbers next to every link. Those numbers are not static metrics. Those numbers are the measure link delay on those interfaces. So 23 is 23 microseconds, 16 microseconds, and so on. I have the ability to do two things before I go into what I'm going to tell you. First, I have to measure the delay of my link. Second, I have to flood that delay value in ISIS or OSPF. And then third, I give it to IGP to compute the path to minimize the delay. And I do have, for that purpose, I have one algo, 128, where I'm going to minimize on delay across all the routers in the topology. Everybody's a member. So the obvious view, assuming IGP metrics are the same, what you see in blue in the lower left is the paths to go from 0 to 9 following IGP metric. Nothing new there. For that, I push the label 16,009, which is the algo 0 label of my destination. What is new is what's happening next. What you see in the lower right-hand side in the green arrow is the delay minimized path from 0 to 9. And that path only follows the path that is shown on the green arrow. That path was computed by the IGP. That path only needs to push one label by the head end. That label is 16,809, which is my prefix seed of algo 128 for my destination. The next use case, which I'm very excited because everything you hear these days is about encryption, security, encryption, security, encryption, security. In this case, we call it the intelligent secure path. I now have a topology that has grown naturally over time, and it includes a mix of encrypted interfaces, MACsec encrypted, hop link by link, and interfaces that are not encrypted. Maybe some of my line cards cannot do encryption, so I only have MACsec in the newer line cards. Maybe some of my nodes are too old, they don't even support MACsec. The newer nodes support MACsec. So what you see on the upper right-hand side is a organically grown topology that includes MACsec enabled and open unencrypted links. The MACsec links are in green, the links without encryption are in brown. I can go in and in a very trivial fashion, I can tell ISIS or OSPF in this topology to install a FlexAlgo instance that avoids unencrypted links. Or I could tell him the opposite, that includes only encrypted links. And then again, the same starting point, ECMP, no restrictions, you see the blue arrows. With a FlexAlgo instance now, defined in the way I told you, I am going to have my path that goes over the green arrow only using MACsec links. And I think the next comment I'm going to make is perhaps the most important. TI-LFA is enabled in this topology. So you are guaranteed, if you have enough topology, to have a backup path. The backup path will be installed less than 50 milliseconds. IGP will converge. Your backup path will only use encrypted links. You will never leave encryption. So you are always encrypted, even for the smallest amount of time, even during backups. That's why this is such an interesting use case. This is another one that is being very pragmatic. It has to do with high bandwidth preference. I think many of you may relate to topologies like this, where the bandwidth on your interface speeds is all over the place. You have super high speed, and low speed interfaces. The goal, not to repeat myself too much, is to go through the topology through, for example, my high-speed interfaces only. I want to go through 100 gigs or above when I'm ready for 400 gig, as an example. And those are the interfaces that I want to traverse. So very trivially now, with FlexAlgo, I can actually tell a FlexAlgo instance to avoid low speed or include high speed. How do I achieve those semantics? I do that by using link admin groups, link colors. So I tell FlexAlgo to include high or exclude low, and you color the links. Same starting point, and with a FlexAlgo that does what I told you about, here's your path that only uses 100 gig or more speed interfaces. If we had more time, we will come back to what is a very top of mind to Cisco, and I hope to customers, is, well, how do I make use of FlexAlgo for multi-domain topologies? I want my SRPCE to compute a multi-domain path that leverages the FlexAlgo as I traverse from domain to domain. Okay? We'll do that next time. In conclusion, FlexAlgo is the newest member of the SRT toolkit, and you should see it as your way to customizing prefix segments to your needs. You will realize a TE path computed by the IGP and enforced with a single label, which has significant benefits. And lastly, you cannot look at FlexAlgo in isolation. You have to look at your vendors and look at the FlexAlgo in conjunction with how can I generate on demand, based on intent, a policy that uses FlexAlgo. How can I automatically put traffic into a FlexAlgo, into a policy that uses FlexAlgo prefix seeds? They all have to go together, okay? This is not Frankenstein. If you want to stay in touch, there are many links in here that you may be familiar with, beginning from the segmentrouting.net website, which I highly recommend. In the bottom, there are some news to share. 2.5 years ago, we released the very first and the only textbook on SR. We call it Part 1. Part 2 is now available in pre-order if you go to Amazon. Part 2 is focused on traffic engineering. And with that, I want to thank you for your time. If there are any questions, please come to the mics. I'll be glad to take 1 or 2 questions. I think I'm over time already. But it doesn't matter because I'm almost the last speaker, right? Thank you.